This conference will now be recorded.
Hey, thanks for joining, Roger sir, for this Tech Talk series. I'm really honored to invite you for my audience. And let me introduce you, Roger sir, to all of my audience. Roger sir, we can say called as Oracle Group, and he has written a book for AWR, and he has own blog, and he is also Oracle Ace Pro, and he has almost 40 plus year of experience in that. He had done so many things related to database administration, performance, and so many things. Okay, so uh, okay, so let's start. So my first question, Roger sir, can you tell me about your journey and how you became interested in working with databases?
Okay, sure. Yeah, believe it or not, I started way back in college as a forestry major, and
Okay,
I was making more money during the summer working as a carpenter than I would have when I graduated. So I dropped out of college for about 3 years, and I did carpentry work. And then I decided to go back to college in 1981 for computer
okay,
science. And I had never
uh,
actually, in 1981, I have never actually seen a computer before in my life.
oh,
So I went back to school for computer science, and I did successfully successfully get the degree, and then started working professionally. Started in 1984 working with hierarchical databases, and
okay,
Oracle in 1984 was just out, right? Um, but I did work my first Oracle database in 1985 with version 4 of Oracle, and
oh,
uh, and one of the things that really hooked me was the set processing capabilities of the database. So I worked for an R&D company that was doing chemical R&D, and they had a lot of laboratory tests and experiments and so forth. And I had to convert a Fortran program from the hierarchical database to Oracle. And I went to the class. I had Pro Fortran. I knew all this stuff. And I started looking at the code, and it's maybe 600 lines of Fortran code. And I'm thinking to myself, this is going to take me 2 weeks to do this. And as I'm, analyzing the problem and so forth, they were reading in a record, doing a calculation, updating the database, reading in another record, updating database, doing the calculation, updating database. And I'm start thinking to myself, I can do this in one SQL statement. So I typed in the
okay.
SQL statement, job was done. Saved myself 2 weeks worth of work. So I basically got hooked, on that set processing capability of the database, way back when.
Okay, great. Thank you. You started from version 4. I started from version 9.
Okay, yep.
Okay. So, can you tell me how you involve in AWR actually and effectively utilize for performance troubleshooting? What is your thought about AWR?
Hmm.
Which
Yeah, I first discovered AWR probably about maybe 15 years ago, and we had a lot of 9i databases and so forth. And it really it's the diagnostics and tuning pack. So actually, the AWR data itself is your access to it is because of the diagnostics pack license. And then if you want to use any of the advisors, then you would have the tuning pack. But you don't really need the tuning pack if all you want to do is look at the AWR data, right? But that it does form the core set of data that Oracle's tools use and all of my custom tools use for diagnosing and pinpointing performance problems. And there are literally tens of thousands of performance metrics in the database, and there are 154 AWR views, so there's a lot of content there.
okay, okay. So, what are the key performance metrics and indicators available in AWR reports, and how can they help in identify the performance issues?
Sure. Well, of course, I mean, most people are probably aware of like AWR reports and so forth. And but since there are 154 views, and I don't even think the AWR report touches all of them, right? But most people would probably think of like top SQL or top wait events, that type of thing. But there are also metrics in there for CPU, I/O, memory, temp table space, redo metrics, undo metrics. So there's tons of metrics out there. And even if you look at service stat, DBA underscore HIST underscore service stat, there are 28 metrics, workload type of metrics for every service that's connecting to your database. So that's another rich source of information. But the go-to would primarily be active session history, DBA underscore HIST underscore SQL stat. That's a big one. And then also sysmetric summary. And there's a system event and system model. Those are big areas to look at too.
Okay, thank you. So, what are the common performance bottleneck actually that can be detected and resolved using AWR data, according to you?
Yeah, well, typically, I guess most people would be looking at SQL level performance metrics, and that would be out of the active session history and also SQL stat. Also, you're going to get, you can actually get information about temp table space usage. So for example, if you get a temp table space blowout, then you can find out who were the top temp table space consumers by looking in the active session history, right? Because there's a, I think in version 11, they added the temp space allocated column to active session history. But even like we've had problems with PGA, so there's also a active session history, a PGA allocated column, so I could find out who are the top consumers of PGA. But also, I mentioned earlier, redo. You can look and see, what's going on with your redo, your undo, DBA underscore HIST underscore undo stat would be the place to look for undo. And then of course I/O, CPU, all those things. But yeah, there's the data's there. The hard part really is because it's scattered in so many different views, right? Where do you go to find it? That's the challenge.
Okay. So, what strategy can be employed to interrupt AWR data and correlate it with specific database activities or events, according to you?
Yeah, sure. And for that, typically, well, you would need to either find the event yourself through some type of monitoring, or you're going to have to get a report of the event from a user. But typically, if it's a user complaint or that type of thing, you would get the date and time and the duration of the event so that you can sort of find out what was going on at that time. And obviously, you're going to want details about the event. Let's say, for example, was it a slow screen, or was it a report or batch job that was slow, that kind of thing. Or maybe even the report is everything's locked up.
Okay.
But so that's one strategy. Obviously, you need to know that get as much details as you can on the event itself. Now, if you do have also when things were running well, so a baseline so that you can compare to. So I almost always ask, okay, so when was the last time this thing ran well? So now I have a baseline that I can compare to what was going on when it ran well versus what was going on when it did not run well. And then, the other approach, I think, which is probably very common, people will look at a handful of their favorite metrics and try to see if, well, I'll look at CPU, or I'll look at I/O, or I'll look at memory, those kinds of things. I call that the small model approach, because essentially you're tailored the metrics to specific known class of problems. Let's say I my book is about anomaly detection, essentially, where I'm instrumenting tens of thousands of metrics, and that's essentially a slightly different, well, not slightly, but it's a major different approach. But you're using the metric values to tell you which ones are abnormal, and then using those to help try to find out what's going on. And the reason why I prefer that, it's more suitable to the arbitrary performance case, whereas the small model approach tends to be because you've handpicked your metrics, it tends to be specific to a kind of problem that you're going to expect to see.
Okay, thank you. So how does AWR data assist in pinpointing SQL statement or database object which cause performance degradation? So what is your input in that?
Yeah. Actually, in active session history would be, you're not going to find SQL metrics anywhere except for active session history, DBA underscore hist underscore active, well, active session history, we'll just put it that way. And then SQL stat, DBA underscore hist underscore SQL stat. Those are the two primary places for SQL level performance metrics. Now, active session history does tell you what object it was on at the time. So if you want to get into the objects that were related to a slow SQL statement, you can actually get that from active session history as well. There are sort of system-wide metrics at the segment level and the object level, and you can extract those. I think the table is called DBA underscore hist underscore seg underscore stat underscore obj, seg stat object. That's another place where I can get sort of object level performance metrics. And then of course there is the segment tuning advisor. So if you do have the tuning pack, you can run the segment tuning advisor, and that's going to basically give you information on those objects that perhaps, let's say, need reorging or things like that.
Thank you. So what are the steps involved in diagnosing and resolving IO-related performance issues using AWR data, according to you?
Okay, yeah. And for me, I would basically, normally, I would sort the SQL by IO, right? So I have some generic queries that I use, and I have different ways of sorting the data. So essentially, the sorting of the query against SQL stat, I could sort by CPU to find the top CPU, or I could sort by IO and buffer gets, other things that are in SQL stat. But generally sort by IO demand for a specific time interval. So let's say if you know that time interval, then try to find those SQL statements. There are other system-wide metrics, and mostly I would go to sysmetric summary. There is a metric in sysmetric summary. It's called asynchronous single block read latency. And that one is essentially telling you what kind of IO latency you have, right? So if there's an IO latency problem, you can actually track that one, with time series and see if I have IO latencies that are really high. And sometimes the IO latencies, if they're really high, they come from the operating system, not the operating system, but the IO subsystem, right? So if I have big latencies that could, IO latencies that could be from the IO subsystem, but typically I would compare the IO latencies to the IO demand. So if the IO demand was super high during the same interval when I had high latency, then generally speaking, I'm not blaming the problem on the IO subsystem. But if I have, let's say, a low IO demand, at the same time I have a high IO latency, then that will kind of make me think that there might be something wrong with the IO subsystem. But then typically, like the guys who run the IO subsystem would skin you alive if you just told them that you suspect a problem without, because they want to know, well, what file? But you can get into those details. You can get very specific, and you can find out what IO, what objects had the high IO and what files they were on. So if you do suspect a systemic problem with the IO subsystem, I would always go deeper into that before contacting the IO subsystem folks.
Okay, thank you. So how can AWR reports be leveraged to optimize memory and CPU utilization in Oracle database, according to you?
Mm-hmm. Yeah, and a lot of that is going to be dependent on the problems that you've encountered. For memory, for example, we had a situation where the memory was limited in terms of PGA allocated. The PGA aggregate limit. We could only bump that up to 100 gigabytes, and there were times where the PGA aggregate limit went high, and you would have blowouts. So we could not exceed 100 gigabytes of PGA. So that that you can just go to. There's a table there called DBA_HIST_PGA stat, and you can find out what was the PGA allocated over time and so forth, and you can find out when you hit those maximum amounts of PGA allocated. But you can also go into active session history and find out, well, what were the major contributors to the PGA usage in a particular time interval, because sometimes the solution is, well, I need to break this job up, right? Or I need to not run these two things concurrently because when they're added together, they will cause PGA blowouts. So having the ability to get down to who are the major PGA consumers through active session history, that's very valuable also.
Okay.
In terms of CPU, typically I would look in this metric summary. They do have a metric in there called post CPU utilization percent, and with that metric, and they're really, I mean, that one's a great table to look at. There's something like, I want to say 150 metrics in DBA_HIST_sys metric summary, and they range, a wide range of workload and IO type of metrics there. But host CPU utilization is one of them, so you can track that over time. Now, most people, I would say, maybe go to the operating system to get that, but it's in a database, and since I like to talk SQL to my data, I go to the database for typically to find that information. Anyway, you can also find, at the user level, what user is consuming the most CPU. You can get that from active session history. If you go to, you can find what SQL are consuming the most CPU by SQL stat, and so forth. So it's usually not that difficult to find that out. And there's some sort of hidden things that with CPU. So for example, if you have logon storms or connection storms, that type of thing, they will tend to consume a lot of CPU. And if you wind up having maxed CPU for a long period of time, you're going to have major problems, because that's going to elevate all the IO wait states. Now, logon storms are not easy to evaluate with AWR, but I know there, at least in the United States, we have a lot of applications that need to be compliant with Sarbanes-Oxley Act. And basically financial applications have to be compliant with Sarbanes-Oxley Act, and which means that the database is logging every single log on and log off, right? And that data is stored in DBA_audit trail. But with audit trail, then now I can detect logon storms through the audit trail. So, and I don't know, to be honest with you, how much that costs in terms of performance. I wouldn't think it's that much to track logons and logoffs, but if you do have that in your application where you are tracking them, then you can go to DBA_audit trail and use that.
Okay, thank you. So what
I think I might have lost your audio.
Yes, I guess you have some problem, I guess.
Yeah, I didn't hear Ahmad.
Yeah. Roger, it would be great helpful if you walk through with a real AWR report would be easy to understand.
Walk through an AWR report.
Yeah.
Yeah, this is actually, let's see if Ahmad comes back in, but I typically, when I use an AWR report, I will, usually I will find out, what the time intervals are that the AWR report was for, and then try to confirm whether that matches the reported performance problem, because sometimes if folks don't always grab the correct interval for an AWR report, but typically you would want to have the smallest interval possible to look at rather than a very big interval, because it's a lot easier to tell what's going on in let's say a 1 or 2 hour time interval versus like a 1 day time interval.
Yeah.
Okay, is Ahmad back?
Yeah, Mother's back.
Okay, so we were talking about,
Power
attendee 7.
disturbance. Okay.
Attendee
Yeah,
7 asked about walking through an AWR report, and the short story for me is I typically won't use an AWR report unless someone just gives me an AWR report and I don't have anything else to go by. But if I do have access to the database, I would, go and check the data myself directly using the custom queries that I have. But if I only have an AWR report, I mean, there's lots of things in there. It's going to tell you the workload metrics from OS stat. So in other words, the load, etc. You're going to be able to find out the CPU. You're going to be able to find the top SQL. At the bottom of AWR reports, if you have tuning pack, also will be an ADDM report, automated diagnostics, database diagnostics and monitoring report. And that's typically a good place to look, because it has some sort of intelligence built into it that Oracle has coded in since version 10 of Oracle to help analyze the problem, the database problem. And of course, the wait events. A lot of people look at top wait events, and I think top wait events are interesting. But when I do the anomaly detection, typically what I'm looking at is unusual wait events. So if your top wait event is something like DB file scattered read or DB file sequential read or something like that, and that might always be the top wait event in every single AWR report you ever look at on that database, then to me, something that's more interesting would be, well, what is the unusual wait event that happened during this problem? And the AWR report is not going to give you that, basically.
Okay. So what role does AWR data play in identifying and mitigating contention issues within the database?
Yeah, and the typical places where people would go would be the system event, right? So that's going to give you the top wait events, and I already sort of gave a little statement about the anomaly detection approach. So unusual wait events. So to me, that's a little bit more interesting than the top wait events. And then also, active session history has the wait events and the wait classes. That, and you can look at those wait classes if you're considered or interested in concurrency or contention issues. Then you could look at those wait events that are a part of that wait class as well. And then, of course, SQL Stat also has wait columns in there. So, and they're sort of aggregated by class. So that will tell you another place to look for those wait events.
Okay, thank you. So what are the best practices for generating and analyzing AWR reports to ensure comprehensive database performance analysis.
Mhm. Yeah, I might have said a little bit about this earlier, but typically you would want the shortest interval possible to look at in your AWR report because if you look at a very wide interval, it tends to sort of smooth a lot of data out. So in other words, if my top SQL happened um, in a certain specific time range, right, then I'm going to want to find out, in that specific time range rather than looking at things that are like before that or after that type of thing. And then if you do have a baseline or a normal interval, and you could do an AWR compare report, that's often helpful as well. And typically, I would take the time intervals from the AWR report and then start digging with my own custom scripts. But I think it will serve you well, most people well, if you can familiarize yourself with what's in the AWR report and then where to go for specific kinds of issues. And it just makes it a lot easier, I think.
Okay, thank you. So how can DBA utilize AWR data to proactively identify the database performance issues before they impact the database?
Mm-hmm. Yeah, and I can tell you a little bit about that primarily from experience and then also what I've seen other people do. I mean, most of the performance problems that I've received, because I'm not actually like an operations DBA, right? The last time I started or stopped a database was in 1987 on a DEC Rainbow microcomputer, AD86,
Okay.
running Oracle version 4 and 640K of memory. But
Okay.
So I haven't really been an operations DBA, but typically, there would be some type of monitoring or thresholds. The kinds of things I've seen most DBAs use obviously would be space, CPU monitoring. Something that's maybe a little bit less unusual or less usual would be like known SLAs for a particular SQL statement or job. And if you know those things, then I think it makes sense to monitor those, because sometimes you'll get plan flips, right, or things like that, and all of a sudden the performance of something will get blown out of the water. But now, of course, that's a very hard thing to do if there are hundreds or thousands of SQL statements, right? But if you had a few key SQL statements for key jobs that you could monitor, then it makes sense to do that. Obviously, if there are hundreds or thousands of them, then monitoring is probably not a very good solution for that. But PGA, we've monitored PGA through PGA stat, and we keep an eye on that and make sure that if you're getting close to having PGA blowouts, then you can check and see, well, what was running. So I'll give you an example. A database normally runs about, let's say, 40 gigabytes of PGA allocation, right? And then randomly, it will peak up to like almost the threshold or almost the limit. So they didn't actually get a PGA blowout, but approached the limit. And when I've dug deeper and found out, well, what were the top PGA consumers, I could see that it was a service call, right? So the people who maintain or who develop the service or maintain it, they don't really know that, they don't have control over how people call it. So let's say an application takes a hold of this service and now all of a sudden calls it 2,000 times in a very short time interval, even though each time it was called, it only used 200 megabytes of SGA. Now all of a sudden, because of the way it was called, it's using or consuming a lot of SGA. So those are sort of like unusual things that are hard to detect otherwise. But if you look in active session history, PGA allocated, you can find that out. Of course, now perhaps you're familiar with the advisors. So there was a segment tuning advisor So segment tuning advisor is good to let you know which objects need to be reorged or could benefit from reorg and so forth. And then there's the undo advisor. Typically, most people will use undo advisor after there was an undo blowout, but you can run that undo advisor because you want your undo retention to be be able to handle your longest run SQL statement, that type of thing. One other thing that I would do is, like, let's say, for example, the users say, well, I can't really tell you what's wrong with the system. I just know that it's always bad. And they don't give you a particular time interval. So in cases like that, you could look at top SQL, but now you have to decide, well, now what interval do I look at the top SQL? So I actually found a way you can query the ADDM advisor, because all the data for the ADDM advisor is stored in DBA_advisor views, right? So I can pull all of the top SQL from that were flagged up by the ADDM advisor, which runs every snapshot interval, right? And then run those through SQL Tuning Advisor. So, and essentially that tells me, is there any low-hanging fruit among the top SQL during this broad time interval? And then, believe it or not, a lot of times you find out, interesting things like SQL profiles or baselines or stats weren't gathered. Other things like indexes, does the ADDM or the SQL Tuning Advisor recommend indexes on these tables? So that's another way to do sort of like a broad brush stroke way to use the AWR. Now the DBA_advisors, they're not part of AWR, but they are part of the tuning pack, and it uses the AWR data anyway, and it's sort of in that framework.
Okay, thank you. What are the limitations of AWR data in performance troubleshooting, and how can these limitations be addressed?
Sure, yeah, that's a good question. And typically what I have found, well, not typically, but across the board, there are very few network metrics instrumented in the database. So a sysmetric summary, out of its 100, let's say 150 metrics, it has one network metric, right? Systat DBA_hist_systat, it might have, let's say, less than 10 or around 10, let's say around 10 metrics related to the network. They're very hard to interpret. There are a number of operating system metrics. The operating system metrics come from DBA_hist_OSstat, and OSstat has probably, I want to say, 20 or 30 metrics in it, so they're not as well instrumented. So network and operating system is not as well instrumented in the AWR as other things, like internal to Oracle and IO and CPU and all that stuff. So the idea here would be, if you wanted to improve that, if you could pull that missing data into the database and query it, then that would be nice. But what most people probably tend to do is they go to other tools. If they suspect the network problem, then they'll get the network people involved, and then network people have specialized tools that they can use to try to go deeper. Same thing if you suspect an operating system level problem, then you might involve the operating system folks to look at their specialized tools. Now, I have actually toyed with this idea, but I've never actually implemented it. But you could write a wrapper PL SQL, right, to run those operating system or network tools and expose that data as a view, right? So you could actually write something in Oracle to pull that data into Oracle so that you could query it directly. But like I said, most people would tend to involve other professionals in the tech stack and
Mm-hmm.
they would use their tools.
Okay, thanks. Thank you. So, how does AWR data assist in capacity planning and resource allocation for Oracle database, according to you?
Mhm. Okay, yeah, and that typically depends on what you're trying to do, right? But let's say, for example, if you were doing a service relocation and you're just
Mm-hmm.
relocating a service from one node to another, if you're say in Iraq, or if you were moving a service to another database, you can actually
Mm-hmm.
go to get the resource utilization from DBA_hist_service stat,
Mm-hmm.
and then you could say, all right, if I add this to my my database, is that going to cause problems? Because you could actually just, well, I've done it.
Mm-hmm.
If you like the one client that I worked with, I could not create database links, so I couldn't link from
Mm-hmm.
one database to another. But if I could link from one database to another, I could just do it in straight
Mm-hmm.
SQL. But if I couldn't link from one database to another, then I just pulled that data out from
Mm-hmm.
the one database and pulled it out from another database, put it in Excel, and then add the data there. But you can actually do that. It's not that difficult. If I'm moving a whole database, right, from
Mm-hmm.
one to another machine or another database, especially if it has existing workload on it, you can get the system-wide workload metrics from Sysmetric Summary. So that's another place to get this system-wide. And then even with PGA stats stuff, I had an example where a product was running and high PGA consuming, but it was running at, let's say, 8 a.m. in the morning, and they wanted to run it at 1 a.m. in the morning with another product that also was a high PGA consuming SQL statement. So I could, literally, I mean, it's really just simple math, but I could find the PGA allocation from the thing when it was running at 8, and then add that to the PGA allocation for the thing that's running at 1, and find out if there's likely to be any blowouts. Some people use for historic things or capacity planning, they will use AWR Warehouse. I don't know how popular that is nowadays, but let's say maybe 5 or 6 years ago, AWR Warehouse was pretty popular, and people were storing, for massive database landscapes, storing their data in AWR Warehouse, so they could do sort of longer term trend analysis that you can't typically do with just AWR data.
Okay, thank you. So, what are the consideration for configuring the AWR retention setting to support long-term performance issues, according to you?
Yep. Well, typically, obviously, the data is stored in sysaux tablespace, so you don't want to fill up sysaux tablespace, right? So you have to have some way of calculating how much space the AWR data is taking or will take, and then make sure sysaux is big enough. Typically, like, let's say, for example, default, I believe, AWR retention period is 8 days. For most environments I've been in, that's not enough, because it only gives you a week. So sometimes you might not even find out. Somebody might not tell you of a problem until a couple of days later, and it might take you a couple of days to analyze it and figure it out. But if you only have an 8-day retention period, then that's very, very limiting. So some applications or systems will bump it up to 30 days retention period. And 30 days obviously gives you more time to look at, but it won't give you the ability, or a very good ability, to, let's say, look at monthly performance problems. So let's say a lot of applications, they have big jobs that run once a month or something like that. If I have only exactly 30 days of AWR retention, that's not going to be very helpful. So some people will bump that up to 45-day retention period, which is better. I typically would look for 140 days of AWR retention to give me that ability to look into quarterly problems. Because a lot of applications that I've been on, they have like once a quarter, something really big runs, and you need to be able to compare that. So if I have a 30-day retention period, and then the problem happened 3 months ago, or something like that, I'm not going to be able to compare it to what it used to run at. So having the 140 days, and for most things that I've done, that's enough. So if you'd only have quarterly things to worry about, then I would say you could probably stick with 140 days. But it's really dependent on sysocs, right? And how big sysocs is. AWR Warehouse, I mentioned that earlier. So a lot of people I've seen, if they want to keep the data for years, they will use AWR Warehouse. And of course, you can always use a poor man's version of AWR Warehouse by snapshotting, the key metrics that you're interested in tracking yourself, right? And you could make your own sort of poor man's AWR Warehouse.
Okay, thanks. So as an average, you can say 145 days is enough for AWR data retention period.
Yeah, I would say 140 days is enough. Yep.
Okay.
For most cases that I've been in. I mean, there are some times that, I've seen this thing where they ran this thing they said they only had to run it once a year, and it consumed 100% of the CPU for 3 days straight.
Yeah.
And it was doing a single row process, rather than a set process. And and then the program finished after like 3 days. It finally finished, and the CPU went back to normal. And so I told them, about this, and I was like, well, we're not going to run it for another year, so we don't want to bother trying to fix it.
Yes. Okay, thanks. So how can AWR data be integrated with other Oracle database performance monitoring and diagnosing tools to provide a holistic view of database performance according to you?
Exactly. Yeah. And I guess with Oracle, observability is a big thing, and it's kind of like a new term, because up until a few years ago, people weren't really, at least to my knowledge, weren't using this term observability. But with the cloud and so forth, observability has become a big thing, and I believe they just sort of lump everything in there, because with the cloud there's so many moving parts, right? And they're all not all inside the database, but they want to be able, to look at those. And although I have not used these tools myself, I'm quite certain that they've incorporated these things into OEM and then other tools within Oracle Cloud Infrastructure. So I think they're already integrated, and they're probably like my biggest complaint with the way it's integrated, or typically tends to be integrated, at least from what I've seen, is like, let's say if it's done in OEM, but I can't access it. If I can't access it from SQL, and the only way I can access it is by sort of marching my way through their screens, it may take me a very long time to find the problem. Whereas I'm quite certain if I could talk SQL to the data, I could find the problem right away. But that's probably my only complaint with most of the observability tools I've seen, is and of course now those screens are good and they're useful, but they typically tend to be built for very specific performance cases. Like, all right, if you want to go to SQL problem, you look here. If you want to look at CPU problem, look here, that type of thing. But if your problem doesn't fit the use cases that they've programmed the tool for, it's going to be a lot harder to find the problem, or to find the problem by navigating your way through their screens.
Okay. Thank you. Thanks. So from my side, I have done. My audience have questions, so they can ask. And before that, you can tell about your book which you have written. If you have copy, so you can display us.
Okay. Yeah,
So
I do
that,
actually. I'll reach over here.
uh, yeah, thanks you so much. Because I think you are the first one who had written this AWR report, book actually. So guys, this is the book Mr. Roger sir has written. So this is very good book, and sir will talk about the book. Yes, sir, please. Yeah.
Yeah, thank you. That the book is primarily about a method that I developed, and really that I was troubled for many years about the fact that there are so many tens of thousands of performance metrics in the
Mm-hmm,
database, and I was
mm-hmm,
using the small model
mm-hmm,
approach like almost everybody else, where I would pick my favorite performance metrics and I would had some code that
mm-hmm,
would allow me to see what the values were for those metrics. But then I started thinking, well, because I couldn't always find a performance problem with the small model approach. So I started thinking there's got to be a way to look at a lot more metrics than what I'm looking at. And actually, it's kind of interesting because my oldest son was working on his PhD in analytics, essentially a data scientist. And and I said, surely you data scientists must have a solution to this problem. And he
great.
just starts rattling off a few things, and he says, oh yeah, we do this thing called feature engineering and feature selection and so forth and
Mm-hmm,
so on, and anomaly detection. And I was like, tell me more, tell me more. So he told me a little bit more, and I started thinking to myself, I can do this in one SQL statement. So
mm-hmm,
I began writing the code for the book, and really, literally, I do the anomaly detection in one SQL statement, right?
mm-hmm,
I began writing the code for it, and then once I got the code written, I started
mm-hmm,
presenting at technical conferences this topic, right?
mm-hmm,
And the editor from A Press contacted
mm-hmm,
me because I was presenting at IOUG in the US,
mm-hmm,
and he said, "Would you like to write a book on this?" And
mm-hmm.
so eventually, I agreed to write the book, and I wrote that book in 4 months.
Oh,
But
great.
it's not like I wasn't really inventing anything new with the book. I was just
Mm-hmm,
essentially documenting in a sort of a deliberate way what I had done, for
mm-hmm,
this approach, this anomaly detection approach. And
mm-hmm.
so it was a good experience, and I make about $1 every book, so if you buy one, if you buy a book, then I'll get about $1 from it. So
Okay. Yeah. Actually, in India, I think it is not only online. We have to order from Amazon, I think. So that I was checking actually. So yeah, great. So when it is published, your book?
this was published in 2018, December 2018.
Okay, 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 okay. Because in India, means many people doesn't know about your book actually. So definitely, I will promote this book to India and other regions through my channels. And
Mhm.
thanks for explaining the things. And guys, if you have any questions, please you can enable your mic and you can ask your questions from Roger sir. So he can answer you guys. Please quickly so that we can wind up this session. Guys, if you have any questions, please ask. One guy had written that please go walk through AWR report. It will easy to understand. See, this is not a technical session. This is just a conversation. So in that we can't do this. If Roger sir allow us, so we can plan a session from Roger sir for AWR report and etc. So that session we can plan later. And
Yeah, actually,
right now, yeah, yeah,
for that
yes,
one,
sir.
I would probably refer you to Craig Shallahammer, because
Mm-hmm.
he's done a lot of presentations and blogs and so forth on walking through an AWR report. And like I said, I
Mm-hmm.
typically, won't use an AWR report unless I have to,
Mm-hmm.
right? So if I can't touch the database and I can't get on there to figure out what's going on,
Mm-hmm.
I'll use the AWR report. But so I don't have a really good sort of story on that, walking through an AWR report. But I know Craig Shallahammer has it, and there's probably
Mm-hmm.
plenty of other sources that you can find online where people are trying to explain this.
Mm-hmm. Mm-hmm. Okay. Okay. So yeah, thank you, Roger sir, for giving me the time, and we had done wonderful discussion on AWR. I think this is the first time anybody had done discussion on especially AWR. So
Mhm.
me and my audience is lucky to have you. So thank
Yeah,
you
you
very
have a
much
good
for
you have
your
a good
time.
audience. Yep, you're welcome.
Thank you. Thank you.
You're welcome.
So
All right.
yeah, you can take leave and we will close this meeting. Thanks. And in future
Great,
we
thank
will
you.
connect soon.
Great. Yeah, thanks for setting this up. And like I said, it's a good audience and a good topic and forum that you have set up here. So thank you very
Okay.
much.
Thank you. Thank you. Thank you, sir. Bye.
Take care. Bye-bye.
Bye. Yeah, guys, we had done. So I'm stopping the meeting. Thanks for joining this session, and we will upload soon. So tomorrow is Eid in India. So happy Eid to everyone, and may God bless you. Thank you. Bye. Take care. Good night.